Welcome to Connectivity Without Chaos, the podcast for IT leaders who are done managing networks by guesswork. In each episode, we break down the systems, strategies, and decisions that eliminate the hidden IT tax, so your infrastructure becomes reliable, secure, and built to scale. Today, we discuss how to navigate the high-stakes complexity of public sector Wi-Fi. So to do this, we're taking a deep dive into some recent case studies and technical white papers on RF modeling today. Basically, our mission is figuring out exactly how IT leaders can survive these brutal, decade-long hardware refresh cycles and, mathematically prove the value of every taxpayer dollar spent on government networks.
Yeah, to really understand that strategy, you first have to look at the financial handcuffs placed on government IT teams. In the private sector, hardware refresh cycles usually run on a pretty predictable, say, 3 to 5 year loop.
Right, which is pretty manageable.
Exactly.
Yeah.
But in the public sector, it's a completely different reality. These networks often just sit untouched for 5 to 10 years, mostly because they're constrained by really rigid bureaucratic budgets.
And, in our industry, 10 years is just absolute agony. It creates this wild feast or famine dynamic, right?
Yeah.
It's kind of like going grocery shopping while you're absolutely starving, but you were only allowed to visit the store once every 10 years.
That is a perfect way to put it.
You are practically forced to hoard, like you're just throwing things in the cart because, you think you might need them in a decade.
Right, which is exactly what leads to all this over-designing and panic buying. Because when that funding finally gets approved, teams face this immense pressure from procurement boards to allocate every single dollar before the fiscal year ends.
Oh, wow. So it's a total use it or lose it situation.
Precisely. So you end up buying for an unpredictable future rather than focusing on what efficiently serves the environment today.
Well, the procurement boards are breathing down your neck, demanding ROI, right? So how do you avoid that panic buying while still proving to some very skeptical taxpayers that your design is justified?
So the answer here requires ruthless future-proofing, combined with highly accurate virtual simulation. First, you really have to adopt cutting-edge standards immediately, like Wi-Fi 7.
Wait, just because it's the newest thing out there?
No, not just because it's shiny and new. Wi-Fi 7 introduces features like multi-link operation, which actually allows devices to send and receive data across multiple frequency bands simultaneously.
Oh, got it.
Yeah, it provides the high throughput and low latency you absolutely need to handle the sheer density of devices we're going to see 10 years from now.
Sure, the specs on paper look great for future-proofing, but I have to push back here a little bit on the deployment side. The sources heavily emphasize using RF radio frequency simulations for virtual rip-and-place upgrades.
Right, testing it virtually first.
Yeah, basically testing how new access points will perform on a digital floor plan before you buy a single piece of hardware.
But how accurate can a digital simulation really be? We are talking about local government buildings that are often like 50-year-old concrete bunkers.
Oh, they definitely are. You can't just slap a 2D floor plan into a program and expect it to know how a wireless signal penetrates a reinforced brick wall,
Well, that's the core difference between a basic drawing and true RF modeling. The software doesn't just look at a flat floor plan. It actually requires you to build a 3D mathematical model of the physical environment.
Oh, so you're inputting the actual physical materials.
Exactly. You assign specific attenuation values to the building materials. So you literally tell the system, hey, this wall is 10 inches of cinder block, this door is solid steel, this is double pane glass.
Okay, that makes a lot more sense.
Yeah. And then the simulation engine calculates exactly how the RF waves will propagate, bounce, and degrade through those specific barriers.
Which I guess prevents that classic knee-jerk reaction in IT. Like when users complain about poor Wi-Fi, the instinct is just to throw more access points at the ceiling.
All the time. But blindly throwing more access points at a problem actually degrades performance. Oversaturating a space without modeling it just destroys the network.
Because of the channel interference.
Yeah. Exactly. Think of Wi-Fi channels like people talking in a room. If 2 people are having a conversation, they hear each other perfectly fine.
Right.
But if you shove 50 people into that same room and they're all shouting over each other on the same frequencies, communication just completely breaks down. The signals literally step all over each other.
And that raises the noise floor so high that devices just drop off the network.
Yeah.
So by simulating the environment first, you avoid making the physical space a chaotic mess of overlapping signals.
You do.
But bringing this back to the IT leader who is sitting in the hot seat, this isn't just about signal strength. It's really about navigating the bureaucracy.
Precisely. This simulated approach allows you to generate a precise bill of materials that is based entirely on math, not guesswork.
Which is exactly what you need for the taxpayers.
Right. You get the meticulous documentation required to satisfy that intense public accountability. You can show a procurement board exactly why you need 50 access points instead of 100 and justify your design choices before you spend a single dime.
I love that. You basically have the receipts before you even buy the hardware, which, leaves you with a really provocative thought to ponder regarding your own infrastructure.
What's that?
Well, what if the connectivity bottlenecks plaguing your current network aren't hardware failures at all, but just invisible channel interference? Like, a simple digital reshuffle of your existing frequencies could potentially fix the problem. And that could save the taxpayers thousands and delay a massive refresh entirely.
If you found this helpful, subscribe to Connectivity Without Chaos on Substack for more insights on eliminating the hidden IT tax. And if you're dealing with a connectivity or infrastructure challenge, send it our way. We may cover it in an upcoming episode.